Have you ever wished a building could just tell you what you need to know? Well, today we're going to look at some amazing research that's doing just that. We're cracking open the AI that's teaching silent digital blueprints how to have a real conversation. I mean, really think about that for a second. What if you could walk up to a digital model of the most complicated skyscraper you can imagine and just ask it something? And not have to wait for some expert to spend hours digging through code. Nope, you just get a smart, useful answer right away, instantly. Well, this isn't science fiction anymore. It's actually becoming a reality. Thanks to some new research, we're seeing how a clever mix of AI technologies can make this happen. It's all about a journey, really, taking this super complex data file, putting it through a few transformations, and coming out the other side with an interactive model that actually understands what you're saying. Okay, so to really get how this all works, we first need to understand the basic problem they're trying to solve. I mean, why can't our digital buildings talk to us in the first place? So, the heart of all modern construction is this thing called Building Information Modeling, or BIM for short. The best way to think of it is as a perfect, super detailed digital twin of a building. Seriously, it knows everything. Every single wall, every window, every pipe, every sensor. It's all in there. But here's the catch. The promise is amazing, right? A digital brain that has all the answers. But the reality is, all that juicy information is locked up tight in a format called IFC. You can think of it like a technical manual written in a language so dense and complicated that only a few specialists with very expensive software can actually read it. For pretty much everyone else, the building just stays silent. So how in the world do you get that valuable information out of its digital vault? Well, the solution starts somewhere pretty surprising. It's not about teaching the AI a new language, it's about drawing a better map. And this is where the researchers had this totally brilliant idea. Instead of trying to force an AI to learn this impossibly complex code, they decided to translate it into something way, way simpler first. It's kind of like taking a 100-page legal document and turning it into a simple one-page summary. All the important stuff is still there, it's just that the connections are suddenly crystal clear. And this shows you that transformation perfectly. It's night and day, right? On the left, that's the original data. It's just a tangled mess, a plate of spaghetti. But on the right, that's the result, a clean knowledge graph. Now the relationship is simple. This wall has this window. It's like they turned that messy spaghetti into a clean, easy-to-read subway map of the building's data. Okay, so now we have a nice, clear map. But how do you ask it for directions? Well, the next step is to bring in a kind of universal translator, one that can speak both computer and human. And this is exactly where a large language model, an LLM, comes in. It's the perfect bridge. You ask a question in just plain, normal English, and the LLM translates it into a very precise query in a language called Cipher, which is just what these graphs are designed to understand. Suddenly, the map can understand you. But hang on, there's a risk here. What if the LLM misunderstands your question? Even a small mistake in that translation could lead you to a totally wrong answer. So, this system has a secret weapon. It's not just one AI, it's a whole team of them working together. So here's how this AI dream team works. First, you've got the generator agent. It takes the first shot at writing the query. Then, the evaluator agent comes in and acts like a quality checker. It asks, hey, is this actually what the user wanted? And if the answer is no, it doesn't just fail. It passes the job over to a repair agent, which looks at the mistake and writes an even better query. And this is what's so cool. It's not a one-way street. It's a self-correcting loop. This team of agents can generate, evaluate, and repair a query again and again, tweaking it each time until the result is absolutely perfect. It's this process that makes the final answers so reliable. Okay, so we've got the simple map, the translator, and the expert AI team all in place. What does this actually look like in the real world? Well, it means you can finally have that conversation with your building. Let's use a real question from the data set they used to test this thing, something an architect might actually need to know. It's pretty complex, right? It's not just find rooms. It has to be a room. It has to be on the top floor. It needs to have a door, and it needs to have at least 2 windows. That's a lot of conditions. And here it is. This is the payoff. The user types in that simple question. The AI team does its thing, translates it, queries the graph, finds the answer. But look, it doesn't just spit out a list of room numbers. It visually highlights the exact rooms that fit the bill right there on the 3D model. The building isn't just talking back, it's showing you the answer. So, just how accurate is this whole setup? Well, the research points to similar systems where just giving the AI a little bit of context from the model boosted its query accuracy to a staggering 99.5%. That's nearly perfect. This approach is seriously effective. This is so much more than just a neat party trick for architects. What we're looking at here is a fundamental shift in how we're going to interact with all the complex data that shapes the world around us. Really, this is about democratizing information. Now, a facility manager, maybe even a first responder, they can all get critical answers without needing to be a software genius. And that means faster, smarter decisions, fewer expensive mistakes, and it really paves the way for a future where our digital twins are true, intelligent partners that we can actually collaborate with. This tech is really just getting started. It makes you wonder, right? If every building, every bridge, every city could instantly answer our questions, what kinds of problems could we solve? What's the first thing you'd ask?